Hello friends, welcome back to your UPSC. Today in Geography of India, we are going to start a new topic, that is climate of India. So let's get started. So climate is weather condition prevailing in an area in general over a long period of time. Okay? So we generally tend to confuse climate and weather. Okay? See, weather is conditions, the atmospheric conditions at a particular time, okay, while climate is a weather condition that is prevailing for a very long period of time, okay. So the general tendency of the weather conditions in the area are known as climate, okay. Now in climate we study temperature, rainfall, atmospheric pressure, as well as the direction and velocity of wind over a long period of time, okay. So the average temperature conditions, the average rainfall, atmospheric pressure, and the direction and velocity of wind that is prevailing in that area for a long period of time is studied in the climate, okay. Now India is actually a vast country, okay. If we look into India, see, if this is India, a tropic of Cancer, this line is passing through it, okay, thus dividing India into its northern section is in temperate region while its southern section is in tropical region, okay. So it has two type of climate, temperate climate and tropical climate, but overall we consider India to be a tropical country having a monsoon type of climate, okay. Now, according to LD Stem, he also stated that India is basically a tropical country, although the northern part is situated in the temperate belt. Okay, so the northern part of India is situated in the temperate belt, but overall, if we consider the climatic conditions of our country, it is tropical climate. Okay, now the climate of India has a unity. Okay, it is a monsoon type of climate, but in unity we see various diversities, uh, regional wise, okay, altitude wise. So we see various diversities in climatic conditions of India. So there is diversity in unity, as in Indian culture it is similar to Indian culture. So the climatic conditions are also diverse, but they are unified and they are in total said to be as monsoon climate. So what are the variations? Now the climatic variations that occur are due to location of the region, okay, altitude of the region, its distance from the sea, and the relief features. We have broad relief features, vast type of relief features in our country, okay. So all these relief features, they also influence the climatic condition in one way or the another. Now if we look into various diversities, we will find that uh, in Rajasthan, the summer conditions, the temperature of summer, it reaches up to the temperature, it reaches up to 48 degrees Celsius to 50 degrees Celsius sometime in Badmer. Okay, it is a desert region in Badmer. While it is about approximately about 22 degrees Celsius in Kashmir. If we look into Gulmarg region and all, it is a pleasant type of climate, okay. That's why in summer vacations people tend to go in these hill stations, okay, to escape the heat. Now if we look into December night, that is cold winter in northern region, okay, so December night are very cold. If we look into Dras and Kargil that are located in Jammu and Kashmir, the temperature it falls to minus 40 degrees Celsius. Okay, so minus 40 degrees Celsius is the temperature in Jammu and Kashmir, while in the same December night, the temperature of Chennai is about 22 to 20 degrees Celsius. Okay, so this is vast type of difference in the temperature conditions. So here we have high altitude as well as it is located in temperate region, while Chennai, it has close proximity with the sea, okay, the ocean region, because of which we have the moderation of temperature by the water body. Okay. Next, if we see about rainfall, we have Cherrapunji and Mawson Ram region, which receives highest amount of rainfall all over the world. Okay, so the rainfall, annual rainfall, it reaches up to 1,221 centimeters annually, while in Jaisalmer it is only about 12 centimeter of annual rainfall. Okay, so we have such a vast amount of difference. Now the Garo Hills, they sometimes receive as much rainfall in a single day as is received by Jaisalmer in 10 years. Okay, so here we can see what a great difference in precipitation. Okay, then we have other set of examples, like we have Ganga Delta and coastal plain of Orissa. They are hit by strong rainstorms uh, almost every 3 or 5 days of third or fifth day of July and August. While the Coromandel coast, thousands of kilometers to the south, it goes dry during these months. Okay, so we can see the variation of monsoon winds also. Okay, now the people in Mumbai and Konkan coast, they do not have to suffer the extreme climatic variation. Okay, but on the other hand, this extreme affects the life of the interior of part of the country, such as Delhi, Agra. So in Delhi we have high amount of, we have scorching heat in summer while we have very cold winters. Okay, so this we can see is great diversity in the climatic conditions of India. Okay, now we will look into various factors which causes this complexity in the character of Indian climate. Okay, so the factors which are influencing the climate of India, the first factor is, if we see, is location of the region as well as its latitudinal extent. Okay, now the mainland of India, we know its latitudinal and longitudinal extent. So here we have, if we consider this is our country, okay, this is our country, then Tropic of Cancer, it passes through it. Okay, so the Tropic of Cancer, it passes and it divides India into two halves. One of the part is in the northern region, okay, that is in the temperate region, and the other one is in the tropical region. Okay, now the tropical one, it has close proximity with equator. Okay, and because of this close proximity with the equator, this area, it experiences high temperature throughout the year. Okay, and the northern part, on the other hand, it lies in the warm temperate zone, hence it experiences comparatively lower temperature. Okay, and some of the places, particularly during winter of northern hemisphere, northern part, okay, northern part, they actually record very low temperature during winters. Okay, the water bodies, they surround the peninsular India. Okay, and they make the climatic conditions of this coastal area mild, because of which the temperature is does not so much affect the peninsular Indian region. Otherwise, this area would have experienced very much of high temperature. Okay, so this was about location and latitudinal extent. The next is distance from the sea. Now, distance from the sea, we see that the peninsular India, we have um, Arabian Sea here and Bay of Bengal here, and we have Indian Ocean. Okay, so it is covered by, it is surrounded by water. Okay, and water, we know water's tendency. Water always warms up. It takes time to warm up as well as it takes time to cool down. And land, on the other hand, it warms up very quickly and it cools down also very quickly. Okay, so because of which we have land breeze and sea breeze. So this land breeze and sea breeze, they moderate the coastal temperature. Okay, because of which we have quite pleasant type of atmosphere in the coastal region. Okay, so we have like maritime or equable climate in the coastal region. And on the contrary, if we look into the interior locations, they are deprived of moderating influence of the sea. Okay, and they experience extreme or continental climate. For example, the annual range of temperature in Kochi, it does not exceeds 3 degrees Celsius. Okay, so the temperature difference is just 3 degrees Celsius annually. Okay, while if we look into Delhi, the temperature difference is as high as 20 degrees Celsius. Okay, so I hope you understood the difference. So coastal area, sorry, coastal area, they are influenced by this water body, because of which their temperature is constant as well as moderate throughout the year, while the interior part, it experiences extreme difference between winters and summers. Okay, now the next factor is a physical factor, that is northern mountain ranges. Okay, now the northern mountain ranges, India actually is separated from rest of the Asia by these impenetrable walls of Himalayan mountain range. Okay, so this is India, and we have impenetrable walls of Himalayas. Okay, if they had not been in the scene, then during winters we have very cold air mass, okay, that flows. So India would have been influenced by this cold air mass, and the climatic conditions would have been very severe. Okay. Further, the mountain, they act as a physical barrier for rain bearing southwest winds. Okay, so first reason is they protect us from the bitterly cold and dry winds of Central Asia, and second is southwest monsoon winds, they strike, they as they come in Indian subcontinent, they strike Himalayas. Okay, and because of orography, okay, they climb Himalayas and they cool down and they form cloud. Okay, so because of orography, they give rainfall to these regions. Okay, so these are two effects of northern mountain ranges. Second, the now fourth factor is physiography. Physiography of India has a great bearing on major effect of climate, such as temperature, atmospheric pressure, direction of wind, and amount of rainfall. Okay. Now, if we look into physical map of India, we will find that it is very closely related to the climatic condition of India. Now, the places that are located on higher altitude, they have cool climate. And even though if they are located in the peninsular India, okay, so we have like Ooty, we have several hill stations, okay. So there also we have quite pleasant type of climate. Then we have various hill stations at the northern mountain ranges, okay. Then we have Himalayan ranges, they are much cooler than the places which are located in the Great Plain of North India. Okay, and the greatest control of physiography in peninsular India is seen in the distribution of rainfall. Okay, so distribution of in rainfall is majorly affected by this physiography. Okay, we will see that southwest monsoon winds from Arabian Sea, they strike almost perpendicular to Western Ghats, which causes copious rainfall. Okay, so it produces high amount of rainfall in the Western Ghats, Western coastal plain. Okay, that is the western slope. Okay, on the contrary, if we look into the area of vast area of Maharashtra, Karnataka, Telangana, then we have Andhra Pradesh, Tamil Nadu, they lie in rain shadow area, or we can say uh, that is leeward side. So windward side is from where the wind attacks. Okay, and leeward side is from where the effect of wind is not seen. Okay, the opposite one. So they lie in rain shadow area, while the western coastal plain it receives a huge amount of rainfall. So Western Ghats it receives either no or very scanty rainfall. Then we have mighty Himalayas that influences the climatic conditions as well. Okay, so the monsoon winds which are brought from Bay of Bengal, they are bifurcated into two branches by the physiographic features. One of the branch it goes to Brahmaputra Valley through the Meghalaya Plateau, and here the funnel-shaped Cherrapunji Valley forces the moisture-laden wind. See, we have this type of valley. Okay, so because of it, what happens is the wind that comes, the huge amount of wind will come. Okay, and they actually concentrate in very small area. Okay, and because of their concentration in very small area, they rises up, and the clouds, very dense clouds are formed. Okay, and these clouds they become heavy, and this area receives very high rainfall. Okay, so the Cherrapunji area is the area which receives, which has recorded highest amount of rainfall in the world. Okay, so this is also due to physiographic conditions. Now next is our monsoon winds. Monsoon we have already discussed in climatology. So monsoon winds, they are most dominating factor in the Indian climate. Okay, and they are so dominating that Indian climate is actually called monsoon type of climate because of their effect. Okay, so the process of monsoon and all the theories related to monsoon we have already completed in our climatology chapter, climatology topic. Okay, so we will jump to next, that is upper air circulation. So upper air circulation it indicates jet streams. Okay, so upper atmospheric circulation, they actually influence the climatic condition of India to a great extent. We have already done jet stream theory, so in it we have discussed how the monsoon is affected by the movement of jet stream in summer and during winters. Okay, so we have two type of jet stream that are affecting the Indian monsoon or Indian climatic condition. First is westerly jet stream. Westerly jet stream actually is responsible for bringing western disturbances from the Mediterranean region to the Indian subcontinent. Okay, so the westerly jet stream, we can simply say that they are the cause of western disturbances that occur in India. Okay, next we have easterly jet stream. Easterly jet stream are reversal in upper air circulation which takes place in the summer. They actually are are the important factor why the Indian monsoon it sometimes is the occurrence of Indian monsoon is delayed sometime. Okay, and why sometimes it comes abruptly. So the easterly jet stream are the cause of it. Next is our tropical cyclone. Tropical cyclone, they originate in Bay of Bengal and Arabian Sea, and they influences large part of peninsular India. Majority of cyclones they originate in Bay of Bengal and influences weather condition during the southwest monsoon season. Okay, some of the cold cyclones they are born in during the retreating monsoon season. Okay, that is in October and November. They influence the weather condition of eastern coastal areas of India. Okay, so the eastern coast they receive sometime they receive cyclonic rainfall in winter. Okay, so we have Tamil Nadu here and Andhra Pradesh, so they receive cyclonic rainfall during winters. That is because of tropical cyclones. Okay. Next, we have western disturbances. Western disturbances, as we all know, we have already discussed in cyclones. They are temperate cyclones which are originated over Mediterranean Sea. Okay, and they travel eastward due to the influence of westerly jet stream. Okay, and they basically influence the weather conditions over most of the northern plain and western Himalayan region. Okay, so because of them, we have a bit of rainfall in Rajasthan region, Gujarat region, and Punjab, Haryana region also. Okay, so they are western disturbances. Next important factor is El Nino and La Nina, and another important factor is southern oscillation. Okay, these two we have to discuss in detail. So let's get started. So first, before discussing their whole phenomenon, we will introduce it. So El Nino is basically a narrow warm current which occasionally appears off the coast of Peru in December, and it is a temporary replacement of cold Peru current. See, in current we have already discussed. So the cyclic cycle of current in Pacific Ocean, we have discussed that the Peru, it is affected by cold current. It is influenced by cold current. But sometimes what happens, this cold current is replaced by temporary warm current. Okay, and this current is responsible for widespread flood and drought in tropical regions of the world. Okay, and sometimes the temperature it becomes more intense, and the surface water temperature of the sea it increases by 10 degrees Celsius. And because of this, the warming of tropical Pacific water affects the global pattern of pressure and wind system, including the monsoon winds in India. Okay, so Indian monsoon is affected adversely by El Nino. Okay, and what is La Nina? La Nina is actually a weather condition, the El Nino condition, when the weather condition they return to normal. Okay, that time normal monsoon cycle it begins, but sometimes the trade wind become very strong. Okay, and they become uh, as they become very strong, there is abnormal accumulation of cold water in the central and eastern Pacific region. Okay, and this event is known as La Nina. Okay, so La Nina, it is complete reverse of El Nino cycle, and in it what happens, the sorry monsoon in India, it is very in very huge amount. Okay, so La Nina conditions are hyper conditions of normal year. Okay, so the normal year, when the conditions in normal year when they become very hyper, that condition is known as La Nina. And after La Nina, there is always it is always seen that we have strong El Nino years. Okay, so La Nina, after La Nina we have El Nino years. Okay, that is why the monsoon it becomes very affected by La Nina as well as El Nino. So if we'll study the effect of El Nino and La Nina. So in normal year, what happens is the frictional drag of easterlies, they accumulate abundant amount of warm water, oceanic water, from Peru coast, towards Indonesian coast. Okay, so the warm water it moves from Peru coast to Indonesian coast because of fractional drag of easterlies. Okay, now because we have huge amount of accumulation of water in the Indonesian coast. Okay, then what happens? The sea water level it rises up to 1 to 2 meter. Okay, and the internal stored energy of water, it increases up to 2 to 3 degrees Celsius. Okay, because of this phenomenon, the air, atmospheric air over this Indonesian coast, they become warm and unstable. Okay, and by the process of convection, they start moving upward. Okay, and conversely, at that time only, the cold water, more and more cold water, it accumulates in the Peruvian coast because of upliftment of cold current. Okay, now here we have extremely low pressure that is generated because of uh, moving of the air upward. Okay, and here we have high pressure that is generated. Okay, while in El Nino, what happens is, because the warm water, it upwells, El Nino current, it accumulates temporarily a warm water here, and the water, it starts moving towards the Peruvian coast. Okay, so this is the normal year and this is El Nino year. Okay, now we will discuss it in map. So during normal year, what happens is, we have cold water in this Peruvian coast. Okay, so the water, due to frictional drag, they move towards the coast of Indonesia and Australia. Okay, and because the water, warm water, it accumulates here, so here low pressure is generated. Okay, and here we all know that during summer, the low pressure is generated in Madagascar and Mascane Islands due to two reasons. Okay, one is because of the shifting of ITCZ, and another is because of easterly jet stream. Okay, so from here also, the water, the air, they moves towards the low pressure belt of Indonesia. Okay, now here we have low pressure, because of which the air, it rises because of convection. Okay, and here high pressure is generated in the upper troposphere. So high pressure, it always moves from high pressure to low pressure area. Okay, so here we have low pressure in upper atmosphere, and the air, it subsides over Madagascar, Mascani Islands of near Africa, and towards Peruvian coast in North America. Okay, so this is the Walker cycle, normal Walker cycle that happens. Okay, now because we have intensified low pressure, intensified high pressure, okay, in this area, okay, and we have low pressure. So what happens is, the wind, they start moving towards the Indonesian coast. Okay, and during this time only, some of the wind, they are taken away as southwestern monsoon wind. Okay, so this is what exactly happens during normal year. So this is the Walker cycle during normal years. Okay, so here the winds are attracted by the low pressure conditions occurring in the Indian subcontinent. Okay, so that is why in normal year we get monsoon. Okay, now what happens in the El Nino year? So if we look into El Nino years, it is named as, or its meaning is child Christ. Okay, here what happens, the coastal cold current which was here, okay, so the cold current is replaced by warm oceanic current, okay, during December. Now the cold Peruvian current that was occurring in this area, that is replaced, and the water, it start moving towards the opposite direction, that is from Indonesia it start moving towards the Peruvian coast in South America. Okay, so the origin of El Nino is explained by sunspot theory. Okay, now according to this theory, when long sunspot gets projected towards the revolving earth, the intensity of solar insolation, uh, an insulation of heating over the earth's surface, it drastically reduces. Okay, by this phenomenon, a prominent low pressure condition does not develop over equator, and pressure gradient between the subtropical high pressure belt and equatorial low pressure belt, it also decreases in the same manner. Okay, the easterlies are now not able to drag abundant amount of warm oceanic water from the coast of Peru to Indonesia. Okay, so from the coast of Peru, if the abundant amount of warm water is not removed, then the cold current is not able to upwell. Okay, and if this phenomenon it sustains for a longer period, then the sea water level near the Peru it subsequently rises, and the low pressure system it develops in the whole region of Peruvian coast. Okay, so now the low pressure condition it develops over Peruvian coast, and in the course of time the slope it develops along the western margin of South America. So the slope it develops along the western margin of South America, which give rise to warm oceanic current known as El Nino current. Okay, now El Nino current has three specific meteorological impact over the onset of monsoon. First is reversal of Walker cycle. Now, during this El Nino year, intense convection starts from the Peru and subsides over. So, intense convection it starts over the Peru and it subsides over. This is high pressure area, and here we have now low pressure area, and it will subside over Indonesian coast. Okay, so here we, instead of having low pressure, we are now having high pressure. And the similar type of convection, it starts from Arabian coast. Okay, so similar type of convection, it starts from Arabian coast and subsides over Indonesia, and it totally changes the atmospheric scenario. That is, high pressure conditions are developed over Indonesia, that is followed by low pressure conditions in Peruvian coast as well as in Arabia. Okay, now the winds they start moving or flowing in the opposite direction, and this whole is known as reversal of Walker cycle. Okay, so now the wind they start flowing towards the Arabian area and the Peruvian area. Okay, now what happens, the wind, instead of moving towards the Indian subcontinent, they are diverged towards the Arabian Peninsula. Okay, because it is having intensified low pressure, because of which the India it receives very low or no monsoon. Okay, so the first condition was reversal of Walker cycle. So here we have El Nino cycle that is built up. instead of normal Walker cycle. So this is Walker cycle or Walker cell, and this is El-nino cell. Okay. Next is the warming of Indian Ocean. Now the wa- warm oceanic water of El Nino, when it merges with the cold Pacific drift, South Pacific drift, it rises the average temperature of South Pacific Ocean. In the course of time, when the oceanic water of Pacific Ocean and Atlantic Ocean they enter in the Indian Ocean, it further intensifies the thermal condition of the whole South Indian Ocean. Okay. Now, after March, with the northward shift of sun, the subtropical high pressure belt of southern hemisphere is over Madagascar and Mascarene Islands that we have already discussed. That the ITCZ it shifts northward. Along with it, the high pressure belt also shifts towards north. Okay, so the Madagascar Mascarene Island during normal year, the high pressure intensifies because the high pressure belt is shifted towards the north. But due to rise in sea surface temperature of Indian Ocean, the high pressure conditions of the area they weaken down. Okay, and because of this, the pressure gradient between the subtropical high pressure belt and equatorial low pressure belt it reduces, and thus the velocity of southeast trade wind and southwest monsoon winds it also reduces, and hence during El Nino years the monsoon is not so intensified. Okay. Now the next is eastward shift of Walker cell. Now eastward shift of Walker cell is actually related with the southern oscillation. So we will discuss it in southern oscillation. But first we will discuss La Nina theory. Okay. Now during La Nina theory, what happens is we have strong Peru current that is here. So we have very cold conditions. Okay. And during La Nina year, we have intensified Walker cycle. So the Walker cycle, we have high pressure conditions here. Okay, and low pressure conditions. Then we have high pressure conditions. But during La Nina year, we have intensified high pressure conditions in the Peruvian coast because we have strong Peruvian current during La Nina year. Okay, and then because we have high pressure conditions, we have intensified low pressure in the Indonesia. Okay, and this is a cause of short sunspot, which are also known as sunspot maxima. Okay, now because of it, how is our monsoon affected? So because we have intensified high pressure and low pressure condition in this area and high pressure condition in this area, so the intensive southwest monsoon wind will be diverted towards Indian subcontinent, and thus we will have intensive monsoon during this season. Okay, or during La Nina year. Okay, so that was about El Nino and La Nina. Now we will look into the new concept, that is southern oscillation. It is also one of the important concepts or one of the important factors which influences the climatic condition of India. So the southern oscillation is actually very related to El Nino year. Okay, so we also sometimes call it El Nino southern oscillation, and together we call them ENSO. Okay, so the southern oscillation is a name ascribed to seesaw pattern of meteorological changes that are observed between Pacific and Indian Ocean. Okay, so there is a seesaw change we can see here. There is a seesaw pattern, and it changes in Indian Ocean and Pacific Ocean. Okay. Now, it has always been observed that when the pressure conditions in the Pacific Ocean they are high, then the pressures over Indian Ocean tends to be low. Okay, and the pressure, as we all know, is inversely proportional with the rainfall. Okay, rate of rainfall. Okay, now it suggests that the low pressure prevails over Indian monsoon in the winter months. Okay, then we have positive southern oscillation. Okay, and the changes in monsoon conditions are also positive. Okay, so the chances are that the monsoon rain will be good. In the opposite case, if the high pressure condition it prevails over Indian Ocean during the winter season, the coming monsoon will be weak. Okay, so the southern oscillation it tells us about the uh, the monsoon conditions. How will they be? Okay, so the southern oscillation it is helpful in predicting the monsoon conditions. So oscillation or the southern oscillation has a period varying from 2 to 7 years. Okay. The intensity of southern oscillation is measured by the difference in the sea level pressure at its station. Okay. And the stations are Tahiti station in mid Pacific and Port Darwin. So we have Port Darwin here. Okay. It is a representative station of Indian Ocean. Okay. So the negative value of Southern Oscillation Index implies the low pressure over Peru current, okay, and higher pressure over the North Indian Ocean during the winter season, and hence we will have poor or indifferent monsoon. So we can see that there is close relation between the appearance of El-nino and negative Southern Oscillation. Okay, so this low or negative phase of southern oscillation is combined with El Nino and it is known as ENSO event. Okay, so ENSO event is when the El Nino and southern oscillation, negative southern oscillation, they are combined. Now, if we look into southern oscillation, it is closely linked with Walker cycle. Okay, with the high pressure, high positive southern oscillation, there would be a zone of low atmospheric pressure over the Australia and Indonesia archipelago. Okay, and it will be accompanied with large convective clouds and heavy rainfall and rising air motion. Okay, now this air eventually turns eastward and after tra- traversing the Pacific area, okay, as a high level uh, westerly wind, it descends over South America. Okay, so during normal year, what happens is this area has low pressure conditions. Okay, so the red is normal year. From here, the normal Walker cycle, we can see normal Walker cycle occurring. Okay, so this is normal Walker cell here and here with the red one. So here we will have low pressure conditions in Indonesia or Darwin station, okay, Port Darwin, and from here the the air will rise up due to convection and it will subside over South American coast, okay, and here near Africa. So this is normal Walker cycle and it influences southwest monsoon positively. Okay, so the positive southern oscillation will give us good amount of rainfall. But during El Nino years, that is during negative southern oscillation, what will happen is the prevailing low pressure over the coast of Peru. Okay, so because we have warm water, that is El Nino current, it causes warm water to come over Peruvian coast. Okay, so it leads to low pressure conditions in the Peruvian coast, and because of low pressure over the coast of Peru, the winds are attracted from different direction, and wind coming from Indonesia to Peru, it also drags oceanic water in the same direction. Okay, so now the oceanic water is dragged towards the Peruvian coast from the Indonesian and Australian coast. Okay, now the water, warm oceanic water, it gets accumulated near the Tahiti Islands located between Indonesia and Peru. So here we have Tahiti Islands which are located between Indonesia and Peru. Okay. Now because of it, what happens is the water near the Tahiti, they start the process of convection, and they create low pressure condition over the surface. Okay. Now the low pressure conditions are created over the surface. Now the low pressure conditions of Tahiti and Central Pacific now attract southwest trade winds towards them. Okay, so the southwest trade winds are attracted towards them, and these respective branches, they have more volume. Okay, so because they have more volume of branches towards this side, okay, towards Tahiti, so there is very less branches that are moving towards Indian subcontinent. Okay, hence because of this, Indian monsoon, it becomes weak. And here we can see, because the winds are moving towards this direction, so here we will have rise, and we will see there is eastward shift of the Walker cycle in this area. Okay, while here we will have reverse Walker cycle. Okay, so this was during abnormal year. Okay, and this reversal of Walker cycle, or we can say negative southern oscillation, it not only affects the Indian monsoon but also the Peruvian coast. Okay, because of this, what happens is the American coast, there the here we have flood conditions and very heavy rainfall. Okay, and here, because of upwelling of cold water, we had various variety of fishes that were collected. But during these El Nino years, we will have less fishing or less fishes that are coming in this area. Okay, so because of it, the fish industry is also affected. So this was about the factors that influence the Indian climate. So let us revise the factors once again. First one was location and latitudinal extent. Then we have distance from the sea. Then we have north mountain ranges. Then physiographic conditions of India. Okay, that is physical features of India. Then we had monsoon winds, upper air circulation, which included westerly jet stream bringing our western disturbances, that is tropical cyclone on Mediterranean Sea. Then we had easterly jet stream. Okay, then tropical cyclones, which influence the mainly the peninsular region and the eastern coast. Okay, then we had El Nino and La Nina effect that affected the Indian monsoon, and lastly we had southern oscillation. Okay, so these are the factors that influence climatic condition. So that was all for today, guys. I hope you enjoyed today's lecture. So let's meet in our next class. Till then, take care and have a nice day.